example tells us that we have a bullet that has a mass of 70 grams. We know that 70 grams is going to be equal to 0.07 kilograms. We also know that it got shot with 2.00 kilojoules of energy, which is the same as 2,000 joules of energy. Because it's talking about the energy of something that's moving, we know that it's going to be kinetic energy. Question A, what it's asking for is it's asking for our velocity. So we know that we can use the formula EK equals half mv squared, and it's looking for velocity. So that means we can divide both sides by half m. The half m gets crossed out on the right hand side, and we know that we can put in our numbers now. So we have 2,000 joules divided by half times our mass, which is 0.07 kilograms, and that is going to equal our velocity squared. So we're going to have to take the square root of both sides, and once we take the square root of the right side, we're going to get that our velocity is the same as 200, or is equal to, and 39 meters per second. That's a fast bullet. In the law of conservation of energy, what B is asking is B is saying that all of this kinetic energy was transferred into potential energy. So if it was all transferred into potential energy, then we know that our potential energy is therefore going to be 2,000 joules. We also know that our potential energy is going to be our mass times gravity multiplied by our height. So in this case, we know that 2,000 joules is going to equal our mass, which is 0.07, times our gravity, which is 9.81 meters per second squared, and we need to calculate our height. So what we have to do here is we have to divide both sides by our numbers here. So we have 0.07 and 9.81. We're going to divide the other side by 0.07 and 9.81. On this side they cancel out. So now we can do our math, do 2,000 divided by 0.07 divided by 9.81, and we are going to get that we have 2.91 times 10 to the 3 meters. Our second example is talking about a cliff diver, and we know that the cliff diver has a mass of 75 kilograms, and we know that he's standing at a height of 30 meters above the surface of the water. Question A is asking us for his potential energy. So our potential energy is our question mark, and we know that our potential energy is always going to be our mass times gravity times our height. So we can put in our numbers here. We know we have 75 kilograms times our gravity, which is always going to be 9.81 meters per second squared, multiplied by our height, which is 30. We're going to get an answer of 22072.5 joules. When we look back at significant digits, we have 2 and 2, so that means we have to give back our answer in 2. So what we can do is we can either put it into scientific notation, so we can say 2.2 times 10 to the 4 joules, or we can turn it into kilojoules, and we can say that we have 22 kilojoules. Either one of those answers would be perfectly awesome. Question B in this case is saying what's his kinetic energy as he hits the water? So as he's hitting the water, we know that when you're up really high, your potential energy is going to be really high. But as you go downwards, your potential energy ends up getting really low. So when you're on the surface of the water, that means that your potential energy is going to be 0. So we know in this case our potential energy is 0. Because of the law of conservation of mass, we also know that because up here we had 22 kilojoules for our potential energy, we know that our potential energy would have had to transfer into something. So we know that our potential energy would have had to transfer into our kinetic energy. Because if we know it's 0 now, the entire thing would have had to transfer into kinetic energy. So therefore, we can say that at the water, because we know that this one's going to be 0, our potential is 0, we know that we will have 22 kilojoules of kinetic energy because our potential energy is 0. Our last question is asking about the speed when he hits the water. So we know that we can calculate speed by doing half mv squared. And in this case, we know our EK already, we know our mass already, so we're just looking for velocity. I can rearrange my formula to find velocity. In order to do that, I need to divide both sides by half m. divide by half m. On the right hand side, my half m's disappear. So I end up with EK over half m equals V squared. And I can plug in my numbers here. When I plug in my numbers in this case, I want to make sure that I use this number that I'm circling right now, the entire thing without rounding. So I'm going to say that my V squared is going to be 22072.5 divided by half times my mass, which is 75. And in order to get rid of the squared, I have to take the square root of both sides. My answer in this case is going to be 24 meters per second. I'm going to box that up.